So today we're going to learn how to add, subtract, multiply, and divide polynomials. Okay. So adding and subtracting polynomials just means combine like terms, right? Polynomials, we know, are just a sum of terms, all of which have coefficients, variables, raised to whole number exponents, maybe some constant terms in there. So you just add up the like terms. And I'm showing you, these are taken from the book, back when I could copy from the book. But now we don't have access to that anymore. I'm not going to tell you like which way you need to add or subtract polynomials. They show two methods here. The one on the left is, they're calling that a vertical format because they put the two polynomials on top of each other. So they're stacked vertically. The one on the right, they're calling a horizontal format because they're written side to side. Okay. Now, if you find either one of those works better for you, personally, I probably always have done, I gotta get my blue going there, like this. I didn't bother like writing them right on top of each other. But I don't mind the way they show that because it kind of relates adding polynomials to like adding numbers. You know, they've loaded up, they've got the constant terms all to the right, and then each degree higher term is to the left. So it does kind of work like adding numbers, other than you cannot add two numbers here and then like carry over to the next column. That won't work. The other thing maybe to say is on the letter B, where they're doing it horizontally, because there's a plus in front of the parentheses, those parentheses really aren't doing anything for you at all. You could just lose the parentheses. And that's kind of what they did, but then in the same step, they got the like terms next to each other, which we probably aren't going to take that step when we add them. You know, I would have probably just like written it without parentheses, 3y to the third minus 2y squared minus 7y minus 4y squared plus 2y minus 5. And then just combine my like terms, right? 3y to the third is the only y to the third. Looks like our y squared are these two terms, so that's minus 6y squared. Come on. There we go. And the y terms are negative 7y plus 2y, and then minus 5. But remember, because there's a plus in between the parentheses, that doesn't really affect anything that comes after it. So you could just lose the parentheses. Now, so I'm going to skip over the you try for that because I don't see it as being much to show. Subtracting is a little bit different. And again, they gave us two different problems, and they said do one of them in a vertical format and one in a horizontal format. Let's just deal with the horizontal format at the bottom. With a minus between the parentheses, right? It does make a difference. That's going to make every term in the second set of parentheses the opposite of what it is inside the parentheses. So I would definitely take a step where I just lose the parentheses, and that's what they did. 4z squared plus 9z minus 12 minus 5z squared plus z minus 3. So it switched these two terms, the sign in front of them. So that's something to keep in mind. I can remember when I went to college, I had taken calculus in high school, one course in calculus, and then I had calculus 2, calculus 3, and series and differential equations in the third course. And you know what? Every time, I would take the first test and I would blow one problem, and there was only 7 problems on the test, so that kind of guaranteed you got a B. And it was always something like a sine. I mean, it's always something like that. It wasn't like with the calculus. It's always in the first step, you didn't distribute the minus correctly. So the attention to detail here is really important. And you know it comes up always, because everything's either positive or negative, and if you make just one little mistake, then you got to be perfect for the rest of the course. So try to do that one. Do the subtract, because I think that's got more. So distribute the minus and then combine like terms. Looks like the highest degree term is going to be d to the third, and you got 2 of them. So how many d to the thirds are there? 8. All right, how many d squareds? 13, right? There was only one d squared term. Okay, how many d to the first? Just the 8. And then the constant terms, -3 plus 4 plus 1. Did everybody get that? No mistakes with negatives? Yes, always leave in standard form. It's kind of unusual that they actually, one of their polynomials was not in standard form. Okay, when you multiply polynomials, okay, you can only multiply 2 at a time, and we will get some where you have to multiply 3 factors, and so that'll multiply 2, and then when you get that product, you multiply it times the 3rd factor. But in any case, I think the SOLs limit it to 5 total terms that you could have to multiply. So you could have to multiply like a monomial, 1 term, times 4 terms, or you could have to multiply a binomial times a trinomial, 2 times 3, that's 5 terms total involved. Or it could be something less than that, you know, or it could be a binomial times a binomial or something like that. But in any case, I mean, the only reason we have this thing called FOIL, because FOIL makes sure that we multiply both terms in each binomial times the other 2 terms. But if it's not 2 terms times 2 terms, then you just have to have some way to systematically multiply all the terms in one polynomial times all the terms in the other. So most of what they're showing us here are a binomial times a trinomial, and they're actually showing 2 different methods here. Now again, the vertical format almost makes it look like long multiplication, right? So you can see how, you know, they've got everything lined up here, and now you would, just like long multiplication, you would start with this number right there and multiply. -2 times -6 is +12. -2 times 3y is -6y. -2 times -2y squared should be +4y squared. Okay, then, just like when you do with long multiplication, usually you have like you move over one space or you put a 0, and then you do the same thing, right? Y times -6, -6y. Y times 3y, +3y squared. Y times -2y squared, -2y to the third. And because they've lined up everything all the way, you can just now add like terms, just straight up and down. Now, I never saw that before. I probably always did it something more like this. In fact, I don't even think that first line right here, I don't think we did that. I mean, we just started multiplying, you know. X times 3x squared, 3x to the third. 3 times 3x squared, 9x squared. X times -2x, -2x squared. 3 times -2x, -6x. I mean, we just kind of just went along systematically, made sure we got them all. Now, let me show you this, though. Oops. That's from my Algebra 1 class. Yeah. I'm going to copy this snippet. So here's another way that you might find useful. And this was taught to me by a kid I taught at Callahan, who was in the military school system in Germany. I don't remember where, but his teacher did it like this, and I thought it was a good way. The class at that time liked it, and ever since I've always said, here's a way you could do it, and it was actually the way that most ended up doing it. You don't have to use it, but if you're getting it wrong doing it another way, I'll probably suggest that you try it anyways. So, draw a grid. Since we're going to multiply 2 terms times 3 terms, I made myself a little grid which is 2 by 3 essentially. Right? I'm going to write down the x plus 3 on the left margin, and I don't need the plus because it's a positive 3. And then I'll put down the 3x squared minus 2x plus 4 along the top. And now I've got a 2 by 3 grid I need to fill in by multiplying what's on the left with what's on the top. Do you see that? So how many terms is this going to make? It'll make 6 terms, right? Some of them will be like terms, but it's going to make us 6 terms. So let's start with the upper left. X times 3x squared is 3x to the third. X times negative 2x, negative 2x squared. X times 4, 4x. 3 times 3x squared, 3 times negative 2x, and 3 times 4, 12. Now, when you do this, usually you're going to find on the diagonals is where you've got the like terms. So the highest degree term is this, 3x to the third. And now we need to add up 9x squared minus 2x squared. Negative 6x plus 4x. And then plus 12. So you can call those other two a vertical format and a horizontal format. I just call this a grid. It's a grid. Had anybody seen anything like this before? Probably you have. Okay. You could end up doing that even for a foil, right? You could do a 2 by 2 like that. This allows you to just expand. If you get 3 times 3, then just make your grid a little bigger and fill them all in. Like I said, the SOLs don't require us to do that. The most that they'll ask us to do is like a 2 by 3, 5 terms. So try to do that one. So how many did their vertical format? How about their horizontal format? How many used the grid? Pretty much. Did you get that? Okay. So no real issues of multiplying two polynomials. Okay, then let's see if we multiply 3. So we have to multiply x minus 5 times x plus 1 times x plus 3. So you can only do 2 at a time, so you just have to pick 2 and multiply them. Now, does it make any difference for any of these, which 2 we pick? Probably not. The one time where it makes a difference, it could make a difference. In the end, it doesn't have to make any difference at all. But for example, and I'm going to erase this after I write it, but let's say that I had this, x minus 5 times x plus 1 times x minus 1. Okay, if that's what I had, I would absolutely multiply the x plus 1 times the x minus 1 first, because that's the factoring of the difference of squares, right? I know what that is. That's x squared minus 1. So it makes all the sense in the world to do that first, right? But if you just have 3 like we've got, no, we don't have anything like that going on. So just pick 2, which I would probably pick the x plus 1 times x plus 3 because they're all positive. So that means my trinomial will be as simple as possible. But you don't have to. You could pick any two that you want. So let me do these two. These two together would be x squared plus 3x plus x plus 3. So that's x squared plus 4x plus 3. Now we need to multiply that times x minus 5. Okay, and for that I'm going to do the grid. Okay. So again, practice with this. X minus 5. X squared, 4x, and 3. Fill in the grid. X to the third, 4x squared, 3x, minus 5x squared, minus 20x, minus 15. Okay, so I'm going to write the answer up here. Looks like we've got x to the third. How many x squareds are there? Minus 1. Negative 20x plus 3x. And minus 15. Okay, so you try one. Yeah, I know, I switched to X. I didn't even realize. Sorry. Any questions about that? So far, not too hard? Okay, so that leaves us most of the time to do dividing. And dividing you might find harder. But it's actually the thing, well, we do all this stuff. And we combine like terms like nothing. I mean, we do that, don't even think about it. We multiply, we end up having to multiply, to go from a factored form to a standard form. But a lot of what we do, really, it's about the division. So polynomial long division works pretty much like long division with numbers works. So before we do a polynomial long division, let's remind ourselves all the things that are involved when we do a long division. Okay, so, and remember the terms here. The 11 is called the divisor. It's the thing you're dividing by. And the 13,574 is the dividend. Okay. And when we divide 13,574 by 11, we're going to put the answer on the top. And what's that called? The quotient, right? So again, think about what's got, first you got to take that 11 and say, how many times does it go into, well, it doesn't go into 1, so you take, okay, what about the first two numbers? Does it go into 13? Yeah, so you got to like estimate a little bit. I mean, 11 makes it kind of easy, but you estimate and you say, okay, it looks like it goes in once. Okay, what do you do with that 1? You multiply the 11, right? And you get 11, okay? Then you draw a line, and what do you do at that step? Then you subtract. Okay, 13 minus 11 is 2. Okay, then what? Bring down the 5, right? And then repeat the process, right? How many times does 11 go into 25? 2 times. So 2 times 11 is 22. Subtract, you get 3, bring down the 7, 11 into 37 goes 3 whole times, 33, subtract, bring down the 4, 11 into 44 goes exactly 4 times, right? 44. Okay, what do you call that number? That's the remainder. Okay, and what does it tell you when the remainder is 0? Say again, Kirsten. Kirsten? Well, it tells you that 11 is a factor of 13,574. So we'll see the same thing when we're doing with polynomials. If we can divide a polynomial by a factor, and we get a remainder of 0, that means it is a factor. It goes in evenly, and that's important. Okay, so a couple years ago, I had a parent at Kickotan. I was teaching his son, but he's like the head of the education department or something at ODU. So we like to get in these long conversations about stuff, and he gave me this journal article to read, which the point of the journal article was trying to predict, based on how kids are when they first get to school, we're saying like 4.5 years old, how will they be when they get to 15? I mean, you might assume that if you're good at 4.5, then you're good at 15, right? And the point of the article was saying, yeah, there is a positive correlation there. But it's a better correlation to measure not how they are at 4.5 with how they're at 15, but how well do they learn that first year and a half, like from 4.5 to 6 years old. Because as you can imagine, if a kid shows up to school on day 1 and they're 4.5 and they already know math, they probably were coached a lot at home. But now another kid who wasn't coached at home but actually learns like really easily, that seems to be a better correlation with how you're going to do at 15 years old. But there was a caveat to that. That was provided 2 things were learned in the middle, right? Somewhere in like 5th grade territory, right? One of them was operations with fractions, and the other one was long division. And you could see with long division, as we went through this, how many different operations did we have to do? Pretty much add, subtract, multiply, and divide. The add maybe not so much. There has to be a little bit of like number sense when you estimate how many times that number on the outside goes into the first few digits, I mean, this one was easy, but a lot of times it's not that easy. Like you could do it wrong and say, okay, I got to make it 1 more or something like that. And not only that, but you have to be fairly orderly about the way you line things up and, do things systematically. You learn to do all that well in late elementary school, and you're on track to succeed in this level. So here's the things to remember about polynomial long division. Okay, we're always dividing a higher degree polynomial by a lower degree polynomial. Okay, both the divisor, which is the polynomial outside, and the dividend, which is the polynomial inside, must not be missing any terms in between the highest degree term and the constant term. And if there are any missing terms, we need to put in a 0 term as a placeholder. So like if it didn't have an x squared, we'd write plus 0x squared, just so that it has an x squared. And I should say up here, in standard form. Good. Jason, busy. Okay, let's do one. Okay, so now I'm going to divide. So we got. So notice right away. What type of polynomial is the first polynomial? What's the degree? 4, right? Now look between the 4th degree polynomial and the constant. Are they missing any powers of x? There's no x squared, right? So when I write this in here, I need to write it like this. 2x to the 4th plus x to the 3rd plus 0x squared plus x minus 1. That's what we mean by if it's missing a power of x. And that's also what we mean by fill it in with a 0 term. Because in the end, 0x squared is 0. But it will give us a place where we can line up the squared terms as we make them. Okay, so now we're dividing by x squared plus 2x minus 1. Okay, that looks better. So now, we need to be focus on the highest degree term inside and outside, right there and there. Okay, and when we were doing long division with numbers, we were saying like, how many times does this go into this? Okay, you can still think of it like that. I usually think of it more like this. I usually think of it as, what would I multiply times x squared to get 2x to the 4th? 2x squared, right? So that's what you're going to put on top. That's the starting point, 2x squared. Now, in long division, once I found that number that I was going to say that's how many times it goes in, what did I do with that number on top? I multiply. So we got to do the same thing, right? Now we need to multiply 2x squared times that whole trinomial, which is outside. So you're going to have 3 terms now, right? 2x squared times x squared. Well, we just did that. We know that that's 2x to the 4th. Then 2x squared times 2x, which is 4x to the 3rd. Then we have 2x squared times negative 1. Negative 2x squared. Okay, so we're done. We did all the multiplying. At this point in long division, what did we do? Subtract. So we got to do the same thing. So I'm going to put it in parentheses like this and put a minus out in front to say I'm about to subtract. And now starting on the right, what is 0x squared minus negative 2x squared? 0 minus negative 2. Plus 2, right? Minus a negative makes it plus. So you got to write 2x squared. And this is, by the way, when we do these, this is always where the mistakes happen. Always. And that's why just use the calculator, do 0 minus negative. If you need to, just get in the calculator, get it right, because if you get it wrong on this very first subtraction, obviously everything afterwards is going to be wrong. Okay, what is 1x to the 3rd minus 4x to the 3rd? Negative 3, right? So negative 3x to the 3rd, and that was a plus. Okay, and now the first term, the 2x to the 4th minus 2x to the 4th, that's 0. We don't need to write that in there. That should be 0 because that's how we picked that 2x squared, which went on top. Okay, now, just like in long division, pull down the next term, plus x. Okay, now repeat the process. Now only looking at the negative x squared here and the highest degree term here. What do you need to multiply times x squared to get negative 3x to the 3rd? Negative 3x. So we'll go minus 3x. Okay, now multiply all 3. Negative 3x to the 3rd. Negative 3x times positive 2x is minus 6x. Negative 3x times negative 1 plus 3x. What's that? Oh, yeah, it's a squared. Sorry. Okay, now subtract. What's x minus 3x? Yeah, and I'm taking this terms right here, negative 2x. What is 2x squared minus negative 6x squared? 8x squared. Okay, bring down the minus 1. One more time. What do you multiply times x squared to get 8x squared? Positive 8. So now multiply all three. 8x squared plus 16x minus 8. Subtract. Negative 1 minus negative 8. 7. Negative 2x minus 16x. Negative 18x. Okay, so now we're done. So again, what does this negative 18x plus 7 represent? It's the remainder. The remainder. And what does it tell you that it's not 0?
It's not a factor.
That this x squared plus 2x minus 1 is not a factor. So usually the way you write it is, okay, so the quotient is 2x squared minus 3x plus 8 plus negative 18x plus 7 divided by x squared plus 2x minus 1. Right? Just like if I divide 7 by 4, I get 1 and 3/4, right? So that's what we're doing. We take the remainder and divide it by the divisor. 131. Better shape. Okay, so try this one. If you can read it. Look okay? There's so many different little calculations you're having to make in there. Just one little mistake and it's going to throw it all off. Okay. Okay. So I'm going to move on. It's okay. So I'm not going to do this one because it just end up being mostly the same, but the difference between that one and that one is that here the divisor was a quadratic, right? And in here the divisor is a linear factor, right? It's linear because it's x to the first, and importantly it's also 1x. So we have there's another way more commonly used to divide when you're dividing by a linear factor, which is 1x plus a number, 1x minus a number. And once you learn how to do it, it's probably the preferred way to do it. And actually, the way this works is, we're going to get a polynomial, maybe it'll be 4th degree, 5th degree, something like that, and we're going to be told, find all the zeros. So because it's 5th degree, we would know it has up to 5 zeros. Some could be real, maybe some are imaginary. And then maybe we could put it in the calculator and look to see if we could identify any zeros right away. If we find a zero, let's say that 2 was a 0, that would tell us that we should divide our polynomial by x minus 2. right? Because if the 0 is 2, the factor is x minus 2. And that will take this cubic polynomial, or whatever our polynomial, and reduce it by 1 power of x. And we keep doing that, finding a 0, dividing it out, until all we've got left is a quadratic. And then at that point, we can finish with the quadratic formula. And so that's why we learned this way of dividing things. So this other process is called synthetic division, which sounds kind of scary, but in the end, given the choice between the two, synthetic or long division, you'll probably say, I'd rather do synthetic division every time. And it's kind of similar. It's actually kind of similar. I think you'll see like where it is in synthetic division is like a similar step in long division. Okay. So I'm gonna show you how to do this. Now, about the first 4 things that I do here, it's not doing synthetic division. It's just setting the problem up. Okay. So the first thing you've got to do is write down the coefficients of the dividend, the bigger polynomial, in a row here. So what are the coefficients? 2, 1, -8, and 5. Okay, now off to the left, make a little box and put in there the 0 from this factor. What is the 0 for that factor? -3, right? Because it's what you plug into that factor to make it equal 0. So -3. So basically, if you see plus a number, you enter in that little box a minus. If it says x minus 3, you'd put in positive 3. But you're putting in the 0 itself. Okay? Now draw a line. Leave a space for another row of numbers, but then draw a line underneath. And last step of setup is bring that first number 2 below the line, like that. That's not a very good arrow. Like that. Bring it below the line. Okay, so now let me change colors so you can see what's going on. Now we're going to take this -3, we're going to multiply it times 2. Okay, this is a multiply. And we're going to put the result here. Okay, so what is that? -3 times 2 is -6. Add. So then you add. You get -5. Okay? Repeat. -3 times -5. Multiply. Put the result there and add. Blue. So that's 15. Oh, I just do. Add 7. Repeat. Right? Multiply this times this. Put the result there and add. Okay. So -3 times 7 is -21. Add, you get -16. Done. Okay, now the last number there, I usually draw a double bar right there, and that is the remainder. And then these numbers, 2, -5, and 7, those are the coefficients of a polynomial of 1 less degree than you started with. So what did we start with? We started with a 3, cubic. So that means these should be the coefficients of a quadratic. 2x squared minus 5x plus 7. And a remainder of -16 over x plus 3. Yeah. That the remainder what? Well, if it's a linear factor, then this thing will always have a, yeah, it can't have an x in it. It's got to be a lesser degree than the thing you were dividing by, since the thing you were dividing by is 1, so it's got to be a constant. That's a good point. Okay. So let me see something here. So before I do that, I skipped over one like this. So just let me show you, like on another one of these, just how fast this can go, right? And that's why it's so much better than writing all that long division stuff, if you can use it, right? So watch how long this takes me, right? 1, -1, 4, -10, right? In the bracket, I need a -2, draw a line, bring down a 1, -2 times 1, -2, add. -2 times -3, 6, add. -2 times 10, -20, add. -30. Remainder is -30, x squared minus 3x plus 10 plus -30 over x plus 2. It's the whole thing. And it took me, what, 10 seconds? So, I mean, you won't be that quick yet, but you'll probably prefer doing this than the long division thing. But again, you can only do that because it's a linear factor and it's a 1x. So try this one for yourself. You can't do it like that. You can make it into something you can do, but you can't do it exactly like that. So go make that your you try. Try to do synthetic division with that. Okay. So one more slide and then we're done. Okay, so I wanted to show you one that's missing a power of x with synthetic division, just so you've seen that one too. They didn't have any examples, so it's coming out of the homework problems. So again, when I write down the coefficients, which is the power of x which is missing? It's just squared. So I'm going to write down coefficients 1, 4, 0, 16, -35. Right? So since it's missing x squared, I got to include that. Right? What am I going to put in the little -5, the 0, right? Now I'm going to draw myself a line, bring down the 1, and start multiplying. -5, 1, -5, -5, 25, 41. Does that look right?
It's -1.
It should have been -1. I knew it was wrong. Okay, try that again. It was -1. That made that a +5. 5. That makes that a -25. 9. -9. That makes this a +45. 10. So the remainder is 10. The polynomial, we started with a 4th degree polynomial, so we should have reduced it to a 3rd degree. X to the 3rd minus x squared plus 5x minus 9. Remainder of 10. 10 over x plus 5. Okay, so that's it. That is synthetic division. That's the homework.